Alright, so what we're going to do now is sort of learn how to do Lewis structures just by counting electrons. Okay, so and then I'll give you sort of the analogy of like how this works. I'll talk you through the process and we'll actually do an example, and then I'll sort of talk about how this works in terms of an analogy for other things that we do. But the first thing that we do in the sort of counting electrons way is we have to draw a skeleton and count valence electrons. It doesn't matter what the order is, but if you're going to draw a skeleton, right, you're going to choose a central atom and then draw the atoms around it. You'll count the valence electrons. Now, you know when you draw a skeleton, you're going to put bonds in it. And so those bonds are electrons that you'll subtract from the total. That'll give you the remaining electrons. And again, you get that. You start with the valence electrons, the total number of electrons, and you subtract the bonding electrons. And then you just take whatever remaining electrons there are, and you just distribute it on the skeleton to make octets. And sometimes you have to make double bonds in order to do this. Okay. If you have any electrons, like if you distribute and you make octets for all the atoms, then any remaining electrons have to go in the central atom. So this is sort of the analogy that I give for this. Like when you're frosting a cake, nobody tries to get it right. Well, people I know don't do this anyways. Maybe you know different people, but people don't try to get it on the frosting on the cake exactly right in the first pass. They get very close and then they smush it around until they fill in all the holes. And so that's basically what we're going to do. We're going to take all the electrons that we know belong on the structure. We're going to put them around the structure in some sort of reasonable way, and then we'll look to see where we have to make adjustments. And so that's basically what this method is. Okay, so we're going to do it with SO3 2-, so sulfite, and we're going to have to choose a central atom and draw a skeleton. So basically, the skeleton is going to go like this. I'll put sulfur in the middle, and then I'll put oxygens on the sides like that. And you'll notice I drew bonds. So remember, every line is 2 electrons. And then I'm going to count valence electrons. So when I count the valence electrons, I'm going to go like this. There's oxygen, there's sulfur, right? Plus 3 times oxygen. Now, you notice we have a charge. Remember how we took care of the charge before? We just added it on the structure at the end. And you can do that, but it's actually common for people to just add the electrons at this point and count them in with the valence electrons. And so this is going to come out like this. 6, because that's the valence electrons for sulfur, plus 3 times 6 for oxygen, plus 2, and that's going to come out to be, this is 18 here, so 6 and 18 is 24, plus 2 will give me 26 electrons like that. So now what I need to do is I need to calculate how many electrons are left, because the rest of the electrons have to go around on this structure. Okay, so to do that, I'll take my valence electrons, which was 26, and I'm going to subtract 3 times 2, and this is the bonds in the skeleton. And that will leave me with 20 electrons. Okay, so now what I'm going to do is take the 20 electrons and distribute the remaining electrons. That's the REs. This guy here is the RE. Right? We're going to distribute it around the outside atoms first and then to the central atom last. So I'm going to do that here. I'm actually just going to redraw it. So I have 20 remaining electrons. I have this as my skeleton. And now what I have to do is distribute my 20 electrons. And for a lot of people, the way they'll do this is they'll just count like 1, 2, 3, 4, 5, right? And they'll draw dots. And so what I'm going to do is I'll draw those dots in these colors like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, why did I do this pattern? Because the goal of putting the dots on is to get to octets, okay? And so by doing this, I got 2 octets by adding, because there's 2 here in the bond, right? So I have 2 here, and then this gives me 6 more. So that's why I added the 6 on there, because I already knew I had 2, so now I've got my 8. I did that all the way around, and now I check the octets, right? And so I'll again finish this off with like this. That's 8. That's 8. That's 8. And then you have to check the central atom too. Don't forget that guy. That guy has 8. So that Lewis structure is done. Now it's an ion. So what you'll end up doing is this. Oops, sorry. My bad. If you don't like drawing all the dots, you can draw it like this, and then put brackets on it like this, and write 2 minus like that, okay? So I just want to warn you real quick. I'm teaching you a way that we do this in Chem 3A, and there are actually further rules about like how you do these Lewis structures that you would apply in a Chem 1A class, right? But we're not doing that. So you'll notice what happens. I Googled sulfite Lewis structure, and look at all the different kinds of structures I got. I got some that in fact have just like we drew it, right? And then I have some that have double bonds on the central atom. Don't use those. That's all I can tell you. If you're trying to check yourself, this is using rules that you're not learning. I want you to learn how we do it in this class, and that's what I'll be checking you on. And then if you have to take a 1A class, then you'll learn the rules that teach you like when you do that. Because sometimes you add a double bond, sometimes you don't. And you need to know what those rules are in order to do that. So anyways, I just want to give you that warning. Like when you do these, like especially for exams or for worksheets, don't be Googling all the answers, because a lot of times these structures include double bonding where we wouldn't draw those. And those would actually get counted wrong in this class, okay? I should also point out that Lewis structures that are drawn with double bonds to the central atom are generally right, but the reality is this is just a model for drawing structures, and oftentimes that's not correct either. And there are better ways to describe it. And so what I'm trying to teach you is sort of the simplest, best way, not necessarily to try apply a bunch of rules that may or may not give you a better answer. There are still some other rules that I wrote down here, but sometimes you have to add double bonds or triple bonds, and that's when you can't make an octet. And we'll do some examples of those. We didn't need it for this one. I may have said that we'll be using it on this one, but I misspoke earlier if I did say that. And then so when we do the addition of double bonds and triple bonds, then we'll be looking for resonance structures like I showed you before. All right, so let's go ahead and do NO2. And we'll draw a skeleton. So for NO2 minus, we're going to draw a skeleton. So one is going to draw, let me do this in blue here. I kind of like the orange, but whatever. We're going to write the skeleton. And again, nitrogen in the middle. Oxygens, it doesn't matter where you put the oxygens, wherever you feel happy putting them. If you wanted to put one down or up, it doesn't really matter. But that's my skeleton. Nitrogen's in the middle. And then total number of valence electrons, right? So 2 is valence electrons. So that first problem took a lot of space, and you'll see here you don't normally need that much space. It goes pretty quickly if you're not drawing everything out like we were doing. So then we're going to go valence electrons. That's going to be 5. That's the number of valence electrons for nitrogen. Again, that's the group number 5. Oxygen is 6, so I'm just going to write this like that. And then I'm adding an electron because it has a negative charge, so I'm going to go like that. And don't subtract. That's a common error. You see the minus, you want to subtract. But when you see a negative charge, you're adding an electron. So this is going to be 12 plus another 6, because 5 and 1, 6. So this will give me 18 total electrons to distribute. Now, I'm going to calculate my remaining electrons. So I'm going to take 18, and I'm going to take 2 times 2, because this is the number of bonds in the skeleton, right? This is bonds in the skeleton. Let's see. Bonds in skeleton. And so that's going to be 14, like that, okay? And then what I'll do is I'll distribute those electrons. Again, starting with the oxygens, the outside atoms first, and if there's anything left, I'll just dump them on the inside. Okay, so now what I'm going to do is go like this. 1, 2, 3, 4, 5, 6, 7. So that gives me my octet, right? There's 2 for this, and then 6 more. And I don't do the nitrogen except for last. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I've given everything an octet except the nitrogen. Now, I've used up 12 electrons, so I have 2 more to give up, right, because there's 14. So the 2, I'll go like this. Now, when you're trying to do this Lewis structure, then the next thing is to check octets. And so we'll go like this, and there's, oh, 8, yay. And then go 8, like this is 8, right? And then you go here, and this one's, the way I always say, is not happy because he doesn't have his 8. So he's going to rely on his friend's oxygen to loan him some. And so this will go like this. We're going to go nitrogen, and then I'm going to bring in another pair from the right side like this. And this side will still be the same. And I'll put brackets around it like this. And this is a -1 charge. Now, having said that, right, I could have done that from the other side. So that means there's a resonance structure, and you can draw it like this. Again, the double bond is on the left side now. Got a lone pair, and like that. Okay? So, oh, sorry. And brackets and a minus charge out here. Now, if you remember, like when we were doing this before, it was that oxygen, like this oxygen, that had the extra electron because that's the one that needed it. But we don't actually go ahead and we don't do that at this level. Again, there's in Chem 1A, we would figure out where all those charges go. All right. Let's see. Draw those structures. I think that's it for that one. So we have resonance structures. Let's go back and review. I had to draw the skeleton. I had to calculate the number of valence electrons, and I calculate the number of electrons that were remaining. I took the 14 electrons and I distributed them on the skeleton. So that's what I did at that step there, right? And then I noticed I didn't have an octet on the nitrogen, and so I needed another pair of electrons to come in and create the bond. So if I bring the electrons in from the right and make a bond here, then that makes this structure. Or if I bring the electrons in on the left, that makes this structure. Remember what I said before, too, like if you get to the end, one of the quick ways you can check your structure is you could just look to see, does it have the right number of electrons? The total number of electrons is 18, and you can actually count that real easy by saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you can just count through the structure. A lot of people will count them in pairs because they're all paired up all the time, so there's actually 9 pairs there. That gives you the 18. Okay? All right, let's do this one. And we're doing a worksheet on this. You'll see it on Monday, I believe. And we'll practice drawing these structures on Monday. We'll practice drawing these structures on Monday, and I'll have some, again, office hours twice a day for all of next week. All right. So we're going to do, you notice I have, the way I've drawn this, I have 2 carbons, and if you remember what I said before, those will be connected together. So I'll end up going like this. The skeleton, by the way, even though I say you could do the valence electrons or the skeleton, I almost always draw the skeleton first. It's just the way I learned to do it. So the carbons are like this. The oxygen will be here. And when you see this, this means oxygen bonded to hydrogen like that. All right, so I'm going to go like that. And then I have to put the rest of the hydrogens on there, and I covered that up. But you'll see that there's a 2 there. So this 2, right, H2 means there's 2 hydrogens on this carbon. So I'm going to go like this. So the skeleton's a little bit harder to draw. And this one has 3 hydrogens on it like this. Now we're going to count the valence electrons, okay? And the valence electrons will be 2 times 4. That's for carbon. And then it'll be, there's 6 hydrogens plus 6, or sorry, 1 times 8, 6. That's for the hydrogens. And then for my oxygen, I'm going to just add 6 more. So this is for oxygen. It's a total of 6. So this will give me a total of 20, I believe. Oops, sorry. I kind of zoomed in accidentally by touching the screen. So that'll be 8 plus 6 is 14 plus 6. Yeah, that gives me 20. Now what I have to do, so this is my valence electrons here. Now my remaining electrons, how many do I have to distribute? Now there's a lot of them in the structure, so let's count the bonds here, right? So I have 1, 2, 3, 4, 5, 6, 7, 8. You notice how I use a different color pen to mark it? Because a lot of times in these structures, when you have a lot of things, it's helpful to like have a highlight or something. So once you count it, you've kind of marked it off so you don't double count. So now I'm going to have 20 minus 14, because that's actually the 2 times the 7. And then that gives me only, oh wait, I think I counted 8. 1, 2, 3, 4, 5, 6. So yeah, I counted 8, sorry. So that's actually 16. And this is actually 8. And then that gives me a total of 4. So then you have to look at the structure. Now every hydrogen just needs one bond. Every carbon has its octet already, right? Because if you circle this, that's 8 electrons, and you circle this, that's 8 electrons, because they're sharing, right? So that means the only place to put the electrons that are left is here. Now everybody has an octet, and that structure is actually done. So this is the Lewis structure for ethanol, the stuff they use in gasoline and drinking things and all that stuff. All right. Just a little note, I talked about this before. Sometimes we have expanded octets. They are pretty common. We won't be doing those in this class, but it's when you have more than 4 groups bonding to the central atom. And also things in group 3A, so like boron. Gallium is in that group. They don't follow the octet rule. Okay,